This is a quick guide on how to use the Starbug's automated power and deflection sweep test. So the first thing you have to do is run the program if it's not running already. You can do this by clicking the run arrow here, and you know it's running because the arrow turned black and the stop sign is red. So the first thing you got to do is check the file paths for the input constants and test data. You can do this by clicking this button here, and you want to click Starbug VF settings.txt and press OK. Next thing is you want to make sure the test path is correct. This is where the data will be stored. So Labview makes this kind of difficult. So if you want to click a certain folder, you have to click the folder, open it, and then press current folder. And that will give you the proper path. If you don't do that, say if you just press this folder and then press open, it's not going to select the folder properly. So you have to make sure you follow this step carefully. And it also says it down here as well. So you'd be doing this, open the folder, press current folder, and you're finished. You can open up the Starbug VF settings by pressing this button here. These are the settings. The settings affect the initial frequency, final frequency, frequency interval. These three settings here, this one, and the peak temperature. Okay, so now this override constants checkbox is very useful. If it's checked, any numbers that you change in these boxes or this one here will be saved when you press the start button. So if you say you want to do a quick test with some different voltage, but you don't want to change anything else, you can uncheck this box and say you just want to put a 1 here. You press start. After the test is done, or if you press stop and the test is done, when you load up the program again, this one will disappear and it'll be back to 50 because it's reading the VF settings found in this TXT. So if you have it checked, all of this will be saved. If you have it unchecked, it won't be saved. Here you can put the Starbug ID. I have a Bertha Outer 1 typed in. This allows you to enable the raw data collection. I'm collecting 6,250 points for 3 different points of data, so the files get very large, and it's not really necessary. You don't really use it for any kind of analysis except maybe to graph the phase of the measured voltage and current. This data here is very important. It has all of the calculations that you need, such as the RMS voltages, Starbug temperature, power and resistance values, and the deflection parameters as well, such as the D31 constant or the peak-to-peak voltage and deflection. Now this output LED lets you know quickly if the output is on or off. If it's on, it'll turn bright red, and this here will say on. When it's off, it'll look like this, and it'll say off. Now, to enable you can enable differential drive by checking this box here. This will allow you to output a positive peak and negative peak voltage into the Starbug. So you have one electrode connected to the outside and another electrode connected to the inside. So if you're, say, outputting 200 volts on the peak positive, then you could, and this will allow you to output a negative peak of minus 200, so overall you get 400 volts. If you uncheck this, you only get a positive peak of 200 volts, which would be a peak to peak of 200 as well, because you're not doing anything differentially. Now these are the limits for the Labview module that we're using. You can output plus or minus 10 volts up to 1 milliamp, and the program is set to output 1 to 350 volts, 350 hertz. Of course, you can do more than that. The input voltage is rated for up to 300 volts RMS. The input current can go up to 5 amps RMS and 250 volts RMS. The program is limited to 8.75 volts, which would be equal to 250 volts RMS differential drive. So if you have a differential drive enabled and you go above 8.75 volts, there will be an error saying that you should lower the voltage. Of course, you can always click I don't care, and it will output 10 volts if you want, or anything higher than 8.75. If this is unchecked, there will be no error. You can put 10 volts and you shouldn't have any problems. So here are the frequency settings. You can change them as much as you want. I think it's maxed out at 350, so if you put 350, it's fine. But if you put, say, 360, it'll go back to 350. which is a good limiter. The initial voltage is limited up to, I think, 10 volts, so you can't put 11. Same thing for the final voltage. Put that back to 0. These are the timing settings. The signal duration is how long the voltage is applied to the Starbug. So here you can set it for seconds or minutes. And you can see how this changes down here. Here it says 28 seconds, but when you put it to minutes, it's 21 minutes and 7 seconds. The restoration is how long you wait between each iteration. So say if we put it for 1 minute, the Starbug will receive a voltage for 3 minutes, and then it'll get 0 volts for 1 minute, and then it'll start again and do 3 minutes on through 1 minute off, like that, until the test is over. Here, now this is a cool feature. This, you can type in the peak temperature that you want the program to stop at. It'll check the thermocouple every second, and if the temperature is above or equal to 80 degrees Celsius, or any other number you choose, the program will stop and it'll give you an error saying that the peak temperature has been reached, and you also receive an email saying that the peak temperature is reached at this time. And to enable this feature, you just check this box here. If you uncheck it, then it won't be working. Wait temperature is also a cool feature. Here I have 20 degrees Celsius, so if I check this box here, after the voltage is finished being applied to the Starbug, if you have this box checked, the program will wait until the Starbug has reached 20 degrees Celsius before it starts the next iteration of the next voltage frequency combination. So this can range from either like 0 seconds, or you can wait up to like 2 or 3 minutes before the Starbug finally cools, reaches 20 degrees Celsius, and then you'll start the next output of the voltage frequency combination. Start the program, press start. To stop it, press stop. This is a test progress bar. This will change as the test goes on. This is a test duration, so whatever values, if you change the values, the test duration will change. You can see how it changed here. This is the elapsed time, so when you press start, you'll see the timer start to go up. These are the email notification settings, so if you want to receive a test completion email, you just check this box. This is the mail server. You type it in here. If you want to test the server, you can put it here, press test, everything looks good, press continue. Here you can put up to 3 recipients, and if you want to enable a recipient email to be sent, you just check the box. If you don't want it to be sent, you just uncheck it, and the person will receive the email. Okay, so these are the live graphs that you'll see when the program runs. Here we have the sine wave that's being output. If you have differential drive, you'll see one sine wave is green and the other one is red, and they'll be 180 degrees out of phase. Here you'll see the output voltage, current output frequency. Phase difference is the difference between the measured voltage and the measured current, not the actual sine wave. This is a graph of the instantaneous power, various power measurements. Here you have the voltage RMS value, the peak voltage. This is the positive peak voltage. Here you'll see a live graph of the measured voltage. This is measured current graph. It also records the RMS current. This is a graph for the Starbug temperature, so it's graphed over 1 minute. You can see how it will change. This is a scroll bar down here, which you can use to see the temperature at various times. This is a Starbug temperature that's seen currently while you're running the test, and this is the maximum temperature that has been recorded so far while the test is running. Now you could also go to the displacement test down here. Here you type in various tube parameters such as the tube length, wall thickness. Sensitivity is 40 millivolts per micrometer based on the calibration sheets that the instrument has. This is the inner diameter here. You can pick between axial displacement test or lateral displacement test. Here you'll see the displacement voltage. It should be an oscillating wave, and here you'll see the peak-to-peak value from the instrument. Here you can see a live graph of the displacement in D31 constant. The displacement is measured in micrometers here on this scale, and the D31 constant is measured here on the right scale, and this is done over time. And here you can also see the actual value being displayed in real time. And of course you can match it up to the temperature while this test is running, so you can see how the temperature affects the D31 constant. And that's it. And if you want to run the program, you just press start, and it'll shut off when it's finished. So it'll eventually look like this.